Alright guys, in this video what we're going to do is we're going to go over a lot of electrical, and right now I'm going to go over low voltage, and I want you to understand how to diagnose low voltage, because there are certain ways that you diagnose low voltage that will cut your time down just tremendously. In our business, there are some things that you have got to completely understand. One of them are pressures and temperatures, like with the superheat, the subcool, the high pressure, suction pressure, low pressure, all that kind of stuff. You got to understand that inside, backwards, forward, every kind of way, and you got to understand electrical. Those are your two main things you've got to understand. If not, you're going back and forth and trying to figure things out, and when you just don't understand it, it's just going to end up causing you to short things out. One, misdiagnose is the biggest problem you're going to have. You're going to misdiagnose a whole bunch of different things, and then it's going to take a lot of your time trying to diagnose. Or how do you find the problem real quick? If you called me and I go, well, did you do this? No, well, okay, put your wire here, do this. Okay, what's this? Okay, well, that's 30 seconds. Well, I've been here for 3 hours and I couldn't figure it out. Well, why didn't you call me after 20 minutes, 10 minutes, 15 minutes when you know you couldn't figure it out and you didn't know the answer? Don't waste all my time, I had this guy, Denny, used to work for me, and he couldn't figure out a particular problem. I forgot what it was. And he was in a building. He's there for 3.5 hours. Well, back then I was paying all my technicians by flat rate. So when you're a good technician, you got paid good money. When you're not a good technician, meaning you're not a good diagnostician, then you don't get paid as much money because you can't diagnose it fast. If you're not a good salesman, you don't make as much money. It's all it boils down to. So guys who are really good with what they do, they made a shitload of money. The other guys got paid for what they know. So Danny calls me up and he's like, man, I've been here for freaking 3 hours, man. I can't figure out what's going on. I said, all right, I'll be over there in a few minutes. He happened to be downtown. I went over there, walked over to the system, and I went, boom, 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 okay, it's this. He's like, man, how'd you find that out that quick? I said, because this voltage and that voltage, you ain't got this, and no, it's this, boom, boom, boom. I mean, within literally 3 minutes, figuring it out. And he's there for 3 hours. And I'm like, why didn't you call me, man? I mean, let's diagnose this thing together. Now, today, with our iPads, okay, which I need to make sure I get your iPad so I can go through all the different stuff, okay? With our iPads, guys, if you can't figure it out in 10 minutes and you're not sure about it, call me on the phone first. Hey, I need to call you on the iPad so that I want to show you what I'm looking at here, so maybe you can walk me through it. Well, show it to me then, okay? I don't have any wires up here for it. So that's going to be a good indication for you that you can walk me through this thing, show me what you're looking at, because I may see something that you're not seeing. So that'll be a good thing. Okay. Let's start here, guys. Let's go with a thermostat. Okay. So first of all, we're going to go ahead and we're going to put a transformer in. Okay. So here's our transformer. We got 110 volts up here, neutral. And we got 24 volts here with a common, okay? Once we come from there, where does that transformer go? We're going to go into our circuit board, right? Well, our circuit board is going to have R, C, Y1, Y2, W1. I should have made this bigger, huh? All right, so we're going to make these terminals a little bigger here. Y1, Y2, W1, W2, G, common, DH, common, and
you had O, B,
O, and then common. All right, so there you go. All right. First of all, what is the R for, guys?
power, 24
Power.
volts.
So power. Okay, 24 volts. Right? What's my Y1 for?
First stage cooling.
First stage cooling, Y2.
Second stage cooling.
Second stage cooling, W1, W2.
First stage heat. Second stage heat.
First and second stage heat, G.
Fan.
Fan, DH.
Dehumidification.
O/B.
Reversing valve.
O/B is reversing valve, and then your common is, or your C is your common, right?
Yeah.
Okay. If I'm reading 24 volts, where do I read 24 volts to? My 24 volts comes to my R and then goes to my C, right? Okay. From my circuit board, now I'm bringing voltage from my circuit board, because you got to remember your transformer is right next to your circuit board, right? So voltage is going in there for that, right? What are you going to have in between here, guys?
Fuse.
A fuse, right? A fuse link.
Fusible link.
Okay? So now, if something shorts out, it blows my fuse and not my transformer, right? So if ever you go to a system and you got a burnt transformer, when you're replacing that transformer, you put a fuse in. Which all you got to do is take two female spades and cut the wire, boom, slice them in there, and then your little fuse will plug right in and put a piece of tape over it. And nothing happens. That's all you got to do. All right. So now you got your thermostat. Now, what we're going to do with your thermostat? We're going to do the same exact thing with your thermostat right here, right? So on your thermostat, you're going to have R, Y1, Y2, W1, W2, G, DH, O/B, and C, right? So this right here is your thermostat. All right. This right here is your circuit board. Okay. Now, from there, we're going to have a condenser, right? So we're going to go ahead and we're going to put our condenser down here at the bottom. And we're going to do this in a two-stage air conditioning system. So this is going to be a two-stage AC. Okay? So you're going to have R, Y1, Y2, C. Right? Now, what if it's a heat pump? I'm going to do the heat pump in a different color over here. And the heat pump is then going to have an O/B. Okay?
Reversing valve.
That's your reversing valve. Okay. So, thermostat, circuit board, outdoor unit. What other deals are we going to have in here? Let's go ahead and let's just go ahead and put our gas valve over here, right? Gas valve, and we're going to put common. And we're going to put W1, W2.
Okay, a float switch also for low
Okay.
voltage.
We're going to do all that. We're going to start adding all this stuff in, guys, is what we're going to start doing. Okay? We're going to do a reversing valve down here, which is just going to be a solenoid valve. Okay? So we're going to do this circle, and we're going to do RV for a reversing valve. So we're going to do here, we're going to do a coil in between it. Okay? We're going to use this two-stage system as a circuit board, is what we're going to do on here. Okay? There is a blower motor inside here as well, right? So let's go ahead and put our blower motor in, and we're just going to put a relay. Let's go up here. We're going to put a relay up here, because I'm going to tell you how some of this stuff works anyway, okay? So this is going to be fan relay. Now, that fan relay is going to be inside your circuit board though, okay? So we're going to do your coil in between here, and we're going to do a normally open and normally closed switch like we did before, okay? What other things we got in there? What's going to energize, guys? Anything else you can think of that might energize, okay? All right. let's do our voltage. Let's do our electrical inside of here. First of all, we're going with 110 volts going up to the top. Let's start up at the top. And before we get 110 volts coming in here, what are we going to have? What is this? A door switch. Okay? Normally open door switch, right? Is it really normally open, or is my door always on?
Well, it's normally open switch, but your door's always on.
It's normally open switch, but my door is always on. Okay? So until you put your door on, you don't get voltage to your transformer, right? Okay. Now my voltage is coming down to my R, always feeding my R. So if I go to my circuit board and I go, hey, here we go, guys. I've got my terminals here, and in between here and here are my separation points. So here's my common energized. So between here and here, I'm reading what? 24 volts, right? Between R and Y, I'm reading what?
Nothing.
Here.
Nothing.
Here.
Nothing.
Here.
Nothing. Nothing. No.
24. What about here and here?
Nothing. Nothing.
Sure.
Yes.
Sure.
Is it
Unless
calling?
unless
You have it calling.
unless you call them from cool.
Okay, well, let's go back over this again then. Okay? Between here and here, what am I reading?
Nothing.
Here?
Nothing.
You're wrong. I'm reading 24 volts. Wow. That don't make sense.
Oh,
does
it's
it?
traveling back around.
It's traveling back around. Okay? Let's go and complete our circuits here. We haven't completed our circuits yet, okay? If nothing is attached here, we read 24 between here and here, but something is attached, okay? So how is it attached? First of all, let's do this. Let's take our R and let's bring it down to our R on our thermostat, right? And then we're also going to take our R and we're going to bring it down here to our R on our condenser, right? So now what are we going to do with our common, guys? We're going to bring our common straight down to our common here, right? So let's go ahead and make our dividers on here as well. Alright. So now, our common now comes from here and goes down to there, right? Okay, so we're feeding 24 there, right? What about our gas valve? What do we need to do with our gas valve? Our gas valve has got to have a common to it as well, right? Now we got 24 volts to our gas valve. How about our reversing valve? Does it need 24 volts to it? Eventually it will if I'm going to energize it, right? So do I need a common there?
Yes.
I sure do, don't I? There's my common. Okay? Well, how about my fan relay? I need voltage to my fan relay, right? Okay? So this one here, that's my common. We actually have to do a little jump over, right? Because it's not touching there. It's actually touching at my common terminal, right? Let's just call it. So with every load, there has got to be a common. So if I was to take one terminal, one lead on my meter, and I want to leave it somewhere, where am I going to leave it at? I'm going to put it here, right? And I go from here to here, and I read what?
24.
I go from here to here.
24.
Here.
24.
Here.
24.
Here.
24.
Okay. If I had something broken between here and here, would I read 24?
Nothing.
I'd read 0. Okay? So, what if I got a broken common right here? Then what do I read?
Nothing.
Zero.
So let's go to my ground. Okay? And I go here to here, and what do I read?
24.
Okay, but I go here to here, and I read
24.
0 because it's broken.
So, yeah, no, I thought you were still on.
Okay.
Got it.
Okay. So R comes down to here, What does my Y1 do, guys? From my circuit board to my thermostat, what does it do? Straight, right?
Straight.
Y2,
Straight down.
W1,
Same thing.
W2,
Same thing.
G,
Same down.
DH.
Straight to.
Okay, that's easy, right? Anybody can wire that up. So nobody should get that confused, right? Okay. Now, got Y1 down here. In between, I'm going to do a float switch over here, guys. And my float switch is normally open and normally closed.
It's normally closed.
Normally closed float switch, right?
Yeah, normally closed. Yes.
It is. Okay. So now, what do I want to break with my float switch?
The R.
Can I break this R, or do I have to break this R going to my condenser? Which one?
I'm going to
the
condenser.
I can break either one, can
Oh yeah, yeah. Yeah.
I? Right?
Mhm.
Okay. On
But do you want to
community.
shut off the condenser and the air handler?
Okay, let me ask you this. If you walk into a house, and I want to shut off my inside unit. I want to shut off this unit here is what I want to shut off. And the reason I want to shut that off, well, if I shut my thermostat off, what runs? Nothing.
Nothing.
What the communicating system was, what they actually want you to do by the book, is they want you to break common. Can you break common with a float switch?
Yeah.
Why can't you?
Yeah, definitely you
Yeah,
can.
they want you to break common with the float switch is what they actually want you to do.
Because you're losing the voltage.
You lose voltage. Okay, you opened up a circuit somewhere, so that's the whole key to it. Okay, so here's what we're going to do in this case. I can break this one, I can break this one, I can break this one, or I can break my Y1 if I wanted to, right? Here's the reason I want to break my power to my R as opposed to my Y. If I walk into the house and my blower motor is running, but my outdoor unit is not running, where am I going to try to find where my problem is?
Outside.
I'm going outside. Where's my problem at?
Inside.
Did I just waste time?
Yeah.
Okay. So I want to break R in the inside to kill my power to my thermostat. If I got no power to my thermostat, where am I going now?
Straight to the problem.
I'm going straight to the inside
Power
system.
source.
And I just cut my time down, didn't I? If I go outside and I have a bad connection somewhere, but I'm still reading voltage outside, but no power is coming, as soon as the load comes, it disappears, then I'm chasing my tail, right? Go straight to the source. That's why I break R. Because I want to kill the power, and I want you to not waste your time and go straight to the problem. You know, if your indoor unit's not running, you're not going anywhere. You're going straight to the indoor unit, right?
Right.
Okay. All right. So where's my voltage go here now, guys? Does it go from my thermostat to my two-stage system, or where's it go from? Where does it come from?
From the circuit board.
Comes from the circuit board. So what we're going to do is we're going to go ahead and take this, and I'm going to run it in a different color is what I'm going to do. And I'm going to bring this down, and I'm going to bring it straight through there just because I shouldn't be running it through there, you know. So Y2, I'm going to bring down, and I'm going to go through it, whereas I should not be going through it, obviously, guys.
Right.
So there you go, okay? I should be going all the way around it to where it's not touching anything, but I'm just running it through my thermostat. Not that it's going through it, I'm just over the top of it. It's 3D. Thermostat sits in back. The wires are over in the front. All right. Okay. So now, when I turn my thermostat on, what am I actually doing? Tell you what I'm going to do is I am going to erase this because it is going to cause me a problem. Okay. All right, and I'm going to bring these from the top. Is what I'm going to do. Okay. Yeah. All right. So now, here's where I'm at. I am going to turn my thermostat on, and when I turn my thermostat on, what does it do? It brings voltage from R to Y, right?
Mm-hmm.
That turns my air conditioner on. What does it also do, guys?
Turn the fan on.
Turns the fan on. So it also brings connection from my Y all the way down here to my G, right? So right now my G, my Y, and my R are connected, right? Now my first stage air conditioner is coming on, right? So if I go from voltage from common to R, what am I reading?
24.
Common to Y, what am I reading?
24.
Common to G,
24.
R to G.
24.
And
Oh no, it's same line. Read
Same
nothing.
line.
Read nothing.
okay? So we just turned the air conditioning system on, and I brought common to R, common to Y, common to G, all reading 24 volts from common to each one of them, right? Okay. So you know you got voltage to that. Now where does it send voltage to? Common to G, which is up here. So I'm going to take this off, and I'm going, G is right here on my circuit board, so it's going to go straight up to here, and my common's already connected, right? So if I got voltage from common to G here, then common to G here, and common to G right here, right? 24 volts, right? So right now my air conditioning's running because I have power from common to G is 24, common to Y is 24, common to R is 24, right? Okay, so if I measure voltage between R and Y, what do I get?
Nothing.
R and G?
Nothing.
There you go. Alright, let's turn the air conditioner off, guys. Nothing is running right now. Nothing is running, okay? And I'm going to move thermostat out right here, and I'm going to write it on the bottom so we can run our wires there. How about that? We can show our connections. So this is still my thermostat. Okay. Nothing is running right now, right? I walk up to my thermostat and I pull the cover off of it, and I go, common to R, what am I reading?
24.
Common to Y, what am I reading?
No.
Common to Y2.
No.
Common to G.
No.
Common to DH. R to Y1.
24 volts.
24 volts. W2.
24.
W1.
24.
G, 24 volts. All of them are reading 24 volts. And the reason is, let's go to your G and figure out why. If I go to my G and I go to my R, I have power coming from my transformer through my board over here over to R. We know we got power at 24, right? So if I go ground to R, I'm reading 24, right? Okay. So I go R and I go over to my G and I'm going to read 24 volts when my thermostat is off, and I pull the cover off and I'm reading 24 volts there. The reason I'm going to read 24 volts is because my power is on one leg, and if I follow this wire up, it follows on through to my common side, on down here to my common on my board. Now, my voltage goes through my coil right here on my fan relay. So that's why when I have power here, and I go to here, it reads all the way through my load, all the way to my common. So from here to here is 24 volts. But when I energize R to G, the reason it doesn't short out is because there's a load in between it. That makes sense? So can you tell if you have a broken coil at your fan relay, like at your thermostat, pull the cover off of your thermostat? I have a broken coil right now. What do I read? R and G.
R to G, 0.
0. If my coil, because my common is broken up here, and my common's coming from here and following up and then coming here, and it's broken, so there is no passageway through all the way to my thermostat to my G, right?
Right.
You want to know why your fan's not coming on? You can tell right there at your thermostat by going R and G, right? There's no voltage. That tells me there's a broken line somewhere. That doesn't tell me there's a broken coil. It tells me there's a broken line not bringing power back to my G. So if I go R to G, that could mean this ain't there, right? It could mean anything. It can mean any of the wiring going from here to here all the way through is something's not connected. Because it didn't follow all the way through the common. Remember, every single coil has got to have a common to it. Every one of them. So if you find your power, now normally we're going to find ground and we're going to trace voltage around. That's normally what we're going to do. Why do we do that? Because our load has got switches in it, has got pressure switches in it, it's got relays in it. Our power has that, our common doesn't. Our common stays common. So you can literally find, a lot of times the blue wire is your common. Sometimes it's a brown wire. But if you look at your relays and stuff like that and you see a blue wire and it's jumped from that one to 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 that, you can go over here and take your common and go, boom, I'm over here on this common, right? Or I can take it right from my transformer, boom, 24 volts, right? And then I can follow my R all the way through my relays and limit switches and float switches and the whole 9 yards, right? So one of them stays still. Remember that. If you go from ground to 24 volts, are you finding all the problems? You may or may not be, depending upon if your ground does have is grounded. Okay? If your common is grounded, okay? If you go common to R and you don't read anything, but you go ground to R and you read 24 volts, you don't have a common. You got bad common. A lot of times on a switch, on a regular light switch, if you're reading 70 volts, your problem is not your power. Your problem is your common. That's very hard to go find, too. It's not because you know what you're looking for. You just got to go find it. So anytime you're reading less voltage like that, 70 volts, 72 volts is what I normally find on it, sometimes 54 volts. If you find that and you're looking for 110 volts is what you're looking for, and you're finding 70 or 50 or something like that, you have a bad common somewhere, okay? Or you have a bad connection somewhere. Because if you have no load to it and there's power to it, you're going to read 120 if there's no load. Put a load to it and it disappears, your voltage was there before you read 120, right? Now you put voltage to it, you're reading 70, it's not running. Well, you had 120, so your power is there somewhere. It's probably your common coming back. Okay? Bad wire, nuts, whatever may be the case, not all connecting. Stranded wire, a lot of your strands are broke off of it and you only got 2 left. You'll read it, but not when you put a load to it, you ain't going to read it anymore because you don't have enough wire to bring the voltage back to it and make that load run. Make sense? Okay. So at this point in time, nothing is on, right? So when we go and turn the air conditioning system on, at this point in time, we will energize R to Y1 over there to G. Now my air conditioning system is energized, right? And we're coming down to our circuit board down here at the bottom in this case, which we have a Y1 and a Y2. Well, right now, is my second stage energized? No. When do you energize second stage? When does it come on?
When the
Below 3 degrees.
when the thermistor reads that it's way hot outside than what it is inside.
No. Your thermostat kicks on Y2. There's normally a 2-degree differential. So if you set your thermostat at 73 degrees, for an example, on a 2-stage thermostat, okay, Y1 will kick in at 74, Y2 at 75. Okay? 2-degree differential. Alright? Now, how else will Y2 kick in? Will Y2 kick in if I just go bury the thermostat down?
Yeah.
It will. But will it kick in right away?
No.
No, because there's a little time delay in between it. Sometimes you got to wait 5 minutes. Here's another kicker. If you've got a zoning system and you put the EWC zoning system on the 50-50 rule, the 50-50 rule will not allow second stage to kick in unless over 50% of the zones are being called for. So if you have 3 zones and 1 is being called for and the 50-50 rule is energized, Y2 will never be energized because only Y1 will be because you are not over 50% of the zones. Okay? That happened the other day to me when I was checking the system out. I had to go turn the other thermostat on so that both systems, both thermostats, are kicking in for the second stage to kick in. Now, once it did it, it sent voltage to my Y2. Now, what happens when this turns over here to Y2? What happens everywhere else, guys? Tell me what happens. Y2 gets energized, right?
Y1 and Y2 energized.
So now Y1 and Y2 are both energized, right? So what happens to my outdoor unit when Y2 gets energized on a two-stage scroll compressor? Tell me what happens in the outdoor unit.
The compressor starts going faster, and
The compressor does not go faster. There's a solenoid valve inside the compressor. It is a relief valve inside the compressor that when you energize Y1, then you are only getting 70% capacity out of that system. When you energize Y2, it actually will energize the solenoid valve inside that compressor. That's why there's two additional wires going over to it, which is 18 to 22 DC voltage going to that solenoid, which comes from the circuit board. Then that energizes that solenoid valve, and you will actually hear that compressor kick into that second stage. Your pressures are different. You cannot charge a two-stage system when first stage is being energized only, because you have a 4-ton evaporator coil, a 4-ton compressor, but it's running at 2.5 tons. Your blower motor is running at 2.5 tons. You're not getting full speed on that system. So on the Rude systems, there is a small C on the circuit board that tells you it's first stage. And then when you see the whole little printout comes out to a big C on it, that tells you it's second stage. Okay? You can't charge this system up and get your superheat and subcooling when it's on first stage. It has got to be on second stage to charge this system properly. Okay? So now that we energize Y2, what happens to G? I don't have a G2. What happens? It's a variable speed system, right? What happens to it? There's no G2. I energize Y2 and W2 and something happens. How come G don't have a 2 on it?
Because you have lower speeds that's in the unit that tells it to.
Because the circuit board inside that system, and this particular one is a 2-stage air conditioning system. This particular one is 2-stage, okay? And all of our 2-stage systems today use variable speed blower motors. Back in the past, it was a lot different, okay? We could actually have a blower relay in there that when energized, when Y2 got energized, it could take the fan off of low speed and then put it on high speed. Okay? So here's the way I would do it with the old Rude systems. If I turn my air conditioning system on and I got a 2-stage air conditioner, listen how this works, okay? Because this is still in effect today when you go out there and see things, okay? My Y1 is normally what color wire for low voltage?
Y1's yellow.
Yellow. Okay, what color is normally Y2?
Blue.
Blue. Okay. On my circuit board, I don't have a Y2, let's just say is the case. Let's just say that's the case. I don't have a Y2. Okay? So but I got a 2-stage air conditioner, but I don't have a Y2, so what am I going to do with my wires? Here's what I do. When I energize my thermostat, when I turn my air conditioning system on, Y1 energizes and G energizes, right? Okay, so all I do from here is I take my Y2, okay, and I hook that up to my Y. And then I take my Y coming from my thermostat, and it just hooks straight up to my Y on my compressor. Then when G is energized, there's a 3 or 4-speed fan motor on this particular system I'm talking about. It's a 4-speed split capacitor motor. Low fan is for heat. You might have a medium low. Medium low might be on the M1, which is a park. Okay. The G, it could be medium, low, whatever you want to put it on. It is a separate blower speed for fan. Okay. So let's say you put that on low. So if you energize G only, G only gives you a lower blower speed, and that is used for filtration. So if you run a low fan speed on filtration, it circulates airflow through, right? And you filter your air in your house. That's what that's for. Okay? So what I would do is I do not hook my Y2, because there is no Y2 on my circuit board. I only hook up Y1. And from my thermostat, I hook Y1 straight to my Y1 on my condenser. So when Y1 energizes, it bypasses my circuit board here, but it energizes my G on my circuit board. So as far as the thermostat is concerned, I'm energizing Y1 and G, but as far as my circuit board is concerned, I'm only energizing G. Follow that? And remember, my G is on low fan, right? Because it's a blower speed for filtration. You follow that? Did I lose anybody? Good? We're good? Okay? So I'm going to say it one more time. R goes to Y1 on my thermostat. That follows up and goes straight to my condenser and then energizes Y1 on my condenser. Because I energized cooling, it automatically energizes G. So anytime Y touches, G's touching too, right? So G gets energized, which energizes a fan relay by itself, which low fan is coming on some of these old systems. So now I got Y1 running on my compressor, and I got low fan running on my air conditioning system, right? Because the fan relay is energized. So now first stage cooling is compressor running in first stage, 70% capacity, blower motor running in low speed. Make sense? Okay. Now, I go to 75 degrees and now second stage kicks on. What happens? Then I energize Y2. Y2 energizes now my Y on my circuit board. When Y energizes on my circuit board, it de-energizes G and energizes the fan relay to turn on high speed for my fan. Different relay. It's just a different relay wired into the circuit board. Not a separate relay out anywhere, okay? It is a relay inside the circuit board, so they got normally open, normally closed, and all that kind of stuff. So when this one gets energized for Y, the G de-energizes and energizes another relay which turns on high fan. That's the way the old two-stage would work. So I can take an old Duquesne furnace, old horizontal, dedicated horizontal furnace, some of the old ones, okay, that only had split capacitor motors and just had a fan relay on it. And all I got to do is add another relay in there, and I can take that 3-speed blower motor, and I've done this before, put a 2-stage air conditioning system on it, go wire that system so I make it work the way I want it to work. And I've done this plenty of times. So do you have to have a variable speed blower motor to make that system work like it's supposed to work? No. Does it work better with a variable speed? Sure it does, because it's made and designed like that. Whereas today's units, I don't even like to tell a customer that I can take their split capacitor motor on that existing furnace and make it a 2-stage system. I don't even want to tell them that. Why? Because you're not getting proper performance out of that system. Will I make it work? Yeah. Have I done it before for that customer? Yes, I have. Let's say that furnace is only 2 years old. Am I going to sell them a brand new furnace when it's 2 years old? No, I'm not. And let's say they want that 16-SEER 2-stage system. I'm just going to make it work the way I know how to make it work. And it's still going to give them 2 stages, still going to lower the blower speed. It's just not going to be perfect like the variable speed will make it perfect, that's all. But it'll be damn close. It'll be close. So yeah, it can be wired properly like that, okay? Does that make sense? Does anybody have any questions on how that's wired? Everybody's good? Clear on it? Okay. Okay. If we have a heat pump, what gets energized? System's off right now. Right? I'm going to turn my heat pump on right now. Okay? And it's 72 degrees in the house, and I want it to be 73. Okay? So it's 72, and I want it to be 73. So I energize my heater, and this is a heat pump. Tell me what energizes, Adam.
No, it would be.
Okay, so I'm going to connect. I'm turning my heater on, right? So I'm going to connect R to O and B. Tell me what's happening right now. O and B goes right down here to my reversing valve, right? So right now, so far, all you've done was energize the reversing valve. Tell me what else happens.
Oh, and G.
Okay, so G is going to energize too, right? So far your reversing valve is energized and your fan motor's running. Are you getting any heat now?
In your furnace. Your W1.
And let's say I have what's called the dual fuel system here.
Okay.
I'm going to call this one the dual fuel system because I'm going to call my W1 and my W2. I'm going to call that a gas furnace for this sake here, okay? So far I've energized O and B because this is dual fuel, and dual fuel means that I have a heat pump for first stage heat and I have gas heat for second stage heat.
Okay.
Okay?
So it's going to hit first stage, so it'll be W1.
So you're telling me I'm going to energize a reversing valve on my condenser, and I'm going to energize the fan motor, and then I'm going to energize my W1, and W1 is going to turn my gas valve on, isn't it?
Yes.
Okay, that's not heat pump, is it? That's gas heat. Now remember, my gas valve is my second stage heat, not my first stage heat. So what am I going to energize now?
You're going to energize W2.
If I energize W2, I got to energize W1 first, and then W2 energizes. Now I've got, again, a gas valve energizing, which is going to run my gas furnace. I'm not energizing my gas furnace. I'm energizing my heat pump. Listen to Gary. Gary knows what he's doing.
Wow.
Gary, what are we energizing?
Y1.
We're energizing Y1. So Y1, right? G and O. So what gets energized right here in my heat pump? Let's think about this, guys. My air condition comes on Y1.
So it could.
My reversing valve energizes, so it reverses my refrigerant flow, right? Okay? What's my second stage of heat?
It's the gas valve.
No, my second stage of heat
Not
is
the
Y2.
Oh, God.
Because it's all running off the outside unit now.
Right. And the heat
Right?
pump.
Because it's running backwards, basically.
I'm running the heat pump. Everybody got that? When you turn a heat pump on, it energizes O and Y1. Then O, and then Y2 second. So now my heat pump's running. Is W energized at this point in time? Well, wait a minute. Y'all said that W was for heat. Why am I not energizing W and I'm running heat? That don't make any sense, right? Because it's a heat pump.
It pumps.
That's why.
The air conditioner.
Okay, can I put a can I put a two-stage thermostat on this system right now, and I have a heat pump condenser? Can I put just any two-stage thermostat on this thing?
No, you need a heat pump thermostat.
I have to have a heat pump thermostat. Because if I have a digital thermostat, programmable digital thermostat, Honeywell 8000 Wi-Fi thermostat, let's just say. It's got all these terminals on it, right? Okay. Now I have to go into the configuration mode and I have to tell that thermostat, I want you to be a single-stage thermostat, a two-stage thermostat, two-stage heat, two-stage cool. I want you to be single-stage air conditioned, two-stage cool. Two-stage air conditioned, single-stage cool. Single-stage cooling, two-stage heating. I want you to be a heat pump, single-stage, a heat pump, two-stage, a dual fuel system, three-stage. I got to tell that thermostat what I want it to be. And it's 1 through 6 or 7 settings. And when you get to number, I'm making this up, when you get to number 10, it says, okay, which thermostat do you want me to be? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I want you to be number 8 because number 8 is a two-stage heat pump. Okay? two-stage heat pump, dual fuel, right? That's what we got here. So if I'm two-stage, that means it knows I got a Y1 and a Y2 and I got it knows that. And it knows I got W1 and W2 too. Two-stage. Okay? Or is this four-stage? What is it? Is it four-stage heating? Yes, it is. It's four-stage heating.
Dual fuel.
I just confused him. How many stages you got to heat, Adam?
I guess you do have 4.
Y1, Y2, W1, W2, don't you?
Yeah, W1 and W2 is once the gas turns on.
Okay, now, how do you get into these modes now? Well, first stage and second stage in my cooling mode, or in my first stage heating mode in my heat pump, right? In heat pump, what am I doing? I'm just energizing a reversing valve that reverses my refrigerant, and I still got a two-stage air conditioner running reverse, right? That's it. Okay? Well, how does it eventually turn into gas heat? How does it eventually happen? Well, what if you go from 71, 72, 73, what if there's a 3-degree differential to kick you into the next stage? That would work, right? So let's just say my heat pump broke. And I need emergency heat. Every heat pump has got to have emergency heat. Could be emergency heat strips, or it could be emergency dual fuel gas heat. Propane heat. Okay? Could be any kind of heat. Alright? I have a geothermal system. Okay? Geothermal system is a heat pump, and I have no backup heat. None. Now, how can I have a geothermal system? And I just got finished telling you all systems got to have a backup heat, right? And I just got finished telling you I don't have a backup heat. No heat strips in my system. If the temperature outside on a heat pump gets 30 degrees outside, is there any more heat outside to bring inside? Because isn't that what a heat pump does? It takes the outside heat and brings it inside the house. What does an air conditioning system do, guys?
Just
It takes the heat inside and it brings it outside, right? So a heat pump takes the heat outside and brings it inside. As your temperature outside drops down, is there any more heat left outside to bring inside? No. So your heat pump is no good anymore, is it? So now you have to have backup heat. I have a geothermal system. A geothermal system, I've got 3 200-foot holes underneath my driveway that these water lines are sunk down 200 feet. The holes are drilled down and they're dropped down 200 feet into the ground, 3 of them. Okay? And the earth is 75 degrees, 78 degrees, right? Okay? Whether it's 20 degrees outside or not, the earth is still the same temperature, isn't it? Well, if it's 75 degrees outside right now and I turn my heat pump on, am I getting heat inside? Yeah, because it's 75 degrees outside, right? So when I turn my heat pump heater on, I am always having a 75 degree day outside. I do not need electric heat. I always have 75 degrees outside. That makes sense? Okay. Heat pump. Don't work like that though, does it? So a heat pump needs secondary heat. So when my heat pump gets too cold outside, then the heat pump no longer works. And there could be an outdoor thermistor that basically is telling you, hey, my outdoor temperature outside is too cold, so it can open up the circuit and no longer feed the air conditioning system in heat pump mode voltage. Then it tells the Y1 and the Y2 basically sending signals and saying, hey, I need for you to go ahead and turn the gas heat on because it's secondary heat. Now, what happens when it gets too cold outside? Can you get a block of ice on your outdoor unit running a heat pump? Sure you can. What if your condenser's dirty outside and you're running your heater in heat pump mode? It's just like having a dirty evaporator coil. You get a big block of ice outside, right?
Freeze up.
Okay. What happens if you run low on refrigerant? It's just like the same thing. You get a big block of ice outside. So a heat pump runs and you get a big block of ice outside and the customer's calling up going, my outdoor unit's got a big block of ice on it. How can you actually defrost that?
Run fan.
Tell them to run the air conditioning. Turn the air conditioning system on for 10 minutes and it will actually reverse the refrigerant back again and your air conditioning's running and you've got hot gas running through your condenser and it will melt that ice like that. Okay? There's a defrost sensor on the outdoor unit on some units, not all units. What does the defrost sensor do, guys? Think about it. How does it do it? It de-energizes the reversing valve, right? And when it de-energizes the reversing valve, it also sends a signal and turns your fan off in the inside.
So it's just running without no.
So there's no fan motor running on the inside, okay? So now what happens is it reverses the refrigerant back around, and when it does, it puts the heat outside and defrosts it. Defrost sensor, right? Freezes up, defrost it, right? So then once it defrosts, then it goes back into the heating mode. Then the heat goes back around in the inside and starts heating up the inside, then the fan can come back on. Do you ever even know it did that?
No.
You have no clue.
Because the inside's turned off, so you don't even know it's even
Right.
doing anything outside.
Now my fuse blew to my outdoor unit. I no longer have any heat pump, right? Fuse blew. Where am I going to get heat now? W1, W2.
Yeah, stage
My
two.
gas heat. My dual fuel system kicks on. Or my electric heat system kicks on. And that's how that heat pump works. Okay? So I never knew how a heat pump worked. I didn't know how it was wired. I didn't know any of it. And I went into Kenny over at Carrier years and years and years ago. And I'm like, man, can you do me a favor? Can you explain to me how a heat pump works? Tell me the wiring of it and how it actually works. So he took about 15 minutes and did just what I did and explained it. And when he explained it to me like that, and I went, oh, the O's energized and the Y's energized. That's how I'm running my air conditioning system, and it goes backwards. Oh, how does my heat strip kick on? Well, that's second stage. So then, therefore, that one kicks off. Oh, when you go to emergency heat, it kicks on Y1, and Y2 is not energized anymore. Or W1 is not energized. No, I'm sorry. Y1 is not energized anymore when you kick in an emergency. W1 is. Okay? Does that make sense?
Mm-hmm.
All right. Did I clear up some of that for you in your head? Okay, good. Okay. Now, what happens, guys, if I am running this system and I am not in heat pump mode? Okay, I'm running my air conditioning system in Y2. And what happens if Y2 is going to energize? I am telling you, it is going to energize a solenoid valve, which is going to bring 18 to 22 DC voltage, and it energizes that solenoid valve in my compressor. What happens if it does not send voltage to that solenoid valve in my compressor? Tell me what happens then.
And you trying to put it in heat?
No, running the air conditioner. So my heat pump is not energized. Only G, Y1, and Y2 are getting energized. But I'm not sending voltage. That circuit board is not sending voltage to my solenoid valve to energize my solenoid valve inside that compressor so that the second stage kicks in.
So the second stage won't never come on.
Right. So just keep running the Y1. Am I getting my full capacity?
No.
Nope. How would you know that? What would you be able to tell? How would you be able to tell that?
You're not getting anything to Y2.
You are getting to Y2 because the Y2 is on your 24 volts. But Y2 going through your circuit board energizes the solenoid valve on your compressor. How do you know? How would you know that Y2 is not getting energized so that you're getting full capacity? Your voltage is getting to your circuit board. It's just your compressor's not kicking in second stage. How do you know that?
Your pressures?
Your pressures. Now your blower motor increased its speed, right? But your compressor's still running in first stage, right? So you need to check that. Check the pressures and temperatures, superheat and subcooling. Always goes back to refrigeration 101, doesn't it? Okay. Anybody not understand this so far? Okay, we're going to go to the next step. Our next step is we're not going to energize our air conditioning system. We are going to energize, actually we are going to energize our air conditioning system. We're in Y1 and we're in Y2 and we're in G. And now we are going to energize DH. Tell me what DH means.
Dehumidification.
Dehumidification, and we learned that when?
Lunch.
At lunch. How much did that cost me? $57.46. All right. Dehumidification. That actually sends voltage to the circuit board, which then on a variable speed system slows the blower speed down about 10, 15, 20%. Okay? If it slows the blower speed down, it makes the coil colder, right? So if the coil gets colder, it removes more humidity out of the air, right? If I remove more humidity out of the air, I dehumidify the home. When I dehumidify the house, the air condition continues to run. So here's what happens. Set your thermostat at 72, guys. It reaches 73. First stage kicks in, right? Can't handle it. Goes to 74. Second stage kicks in, right? Cools back down to 72. Thermostat is set at 50% relative humidity.
It's going to go 3 degrees less.
It's going to say, hey, wait. Don't shut off. Don't shut off. Stop. Don't shut off. Air conditioner, keep running. Blower motor, slow your speed down here, bud. Slow your horses down. Because this guy's telling me he wants his house to be a little bit more dehumidified than where we're sitting at. Slow your speed down, guys. Now, let's get this coil cold for this couple here. We're going to get the coil cold, we're going to pull some humidity out of there, and we're going to get them nice and comfortable. So they do that. Slows the blower speed down, that goes from 72 to 71, right? Then it keeps going because it's still not satisfied yet. It goes to 70, then it's still not satisfied yet. It'll go to 69 degrees, 3 degrees below set temperature, and then it will stop overcooling the home. That actually can become a little bit uncomfortable because you start getting too cold in the house. You were originally set at 72 and it's going down to 69. That's a little bit uncomfortable, to be honest with you, because I've lived in a house like that. And it's a little bit uncomfortable. It gets cold when we do that. So I set my thermostat, instead of on precision, I set it on normal, where it would go into dehumidification, but it wouldn't cool down that much. Okay? The variable speed systems today will increase and decrease its blower speed and maintain that humidity level in the house. So the algorithms in that thermostat, in the outdoor unit, and the humidity settings and all that kind of stuff, man, it gives you just precise settings on your blower speed and your compressor, and it gives you maximum dehumidification in the house. So if you want good dehumidification in the house, variable speed air conditioning is the way to go, guys. Okay? So now let's go ahead and let's turn dehumidification on. And we dehumidified the house. We lowered the temperature setting in the house. We didn't lower the temperature setting. It did it automatically, right? So once it did it cooled back down. It shut itself off. Now next time it kicks on, what temperature is it going to be in the house? Well, I'm going to tell you this. If the humidity level is still higher than what it needs to be, it'll still go up a couple degrees and then dehumidify right on back down 3 degrees below. If that's the way it's set.
So it'll say if it's set on 73, and
it'll cool down to 70. And then if it's still calling for dehumidification, it's going to lower that temperature down to 70 now. It's like you got your thermostat set at 70 now,
okay,
instead of 73. Okay? All right. W1, W2. Gas heating system. Straight gas heating system. No heat pump here, guys. Okay? You turn your heater on. You set your thermostat at 70 degrees. When it reaches 69 in the house, first stage of heat comes on. How much capacity are you running on a 100,000 BTU gas heater in first stage?
70%.
70% capacity. At what blower speed are you running now? 70% of your setting for your cool. Okay? So if I got a 100,000 BTU system, okay? I'm sorry. Let me back up. I said it wrong. You're going to run 100% capacity. In second stage, if you have, let's call it 1,000 CFMs in second stage, you're going to run 70% of that 1,000 CFM setting for second stage. Not cool. Second stage heat. Okay? I said it wrong. All right? So first stage kicks in at 1 degree below temperature. The second stage kicks in at 2 degrees below temperature. Okay? And then it warms the house back up to whatever temperature you have it set at, shuts the system off, boom, cools back down. First stage kicks back on, heats it back up, and stays within 1 to 2 degrees. Okay? That's the way your heating system works. Everybody understand that? Alright? Anybody not understand what we got right here so far? Okay, so what we're going to do right now is, I want you to really take a good visual of this board. Picture it, picture it, picture it, because it's fixing to go away and you're going to do it.